There's an optional component to the if statement that I haven't shown you yet. It's called the else, or the else clause. Recall that if statements work like this. If a condition is true, then perform some code. Well, the full picture looks like this. If condition is true, then perform some code. Otherwise, perform different code. If condition true, perform code A, else, I notice I use the word else there, perform code B. So it looks like this. It's an optional addition to the if statement, following on immediately after the code that gets executed if the if statement is true. And else can be thought of as the words, otherwise do this. So if a condition is true, do this, otherwise do this. For example, if my car is clean, go for a drive. Else, clean my car. Okay, I'm now going to show you some coding examples using if and else. This is age2.c, following on from the last example regarding the if statements. Demonstrate if else. Okay, recall this is what we had before. If age is greater than magic age, say you are very old. I'll now show you how to put an else clause at the end of this. We use else. Now we have the option of either using a block or a single statement, just like we had the same option after the if statement. I'm going to, in this case, not choose a block. I'm going to choose a single statement instead. Printf, you are only young. And that's almost all there is to it. Let's just check that that works. Compile and run. Please enter your age, 45. You're very old. Okay. Let's try it again. You are only young. Okay, so the program is doing different things depending on the age that we enter. Excellent. So you can see the if statement with its associated else is very useful for differentiating between two different possibilities. But what if there are three different possibilities? What if we're trying to determine whether people are older than 40, or younger than 40, or exactly 40? And for that matter, what if there are more than three options? Well, let's focus first on the three options. I want to try and code that exact example. I want to do one set of code if we're older than 40, another set of code if we're younger than 40, and another set of code if we're exactly 40. You might be wondering how to do that. If we've got a condition here that can only ever be true or false, how do we get three different cases out of it? And the answer is, well, we're not just going to use one if statement, we're going to use two if statements. So, let's see how that looks. I'm going to go down into this else now, and I'm going to turn it from a single statement into a block. In other words, I'm going to put braces around it. And then, inside here, I'm going to say if age is less than, see that's the symbol for less than, the magic age, then certainly say you are only young. And here I'm going to put another else, printf, you are the perfect age. Okay, let's have a look. We've got now quite a large and possibly even complex if statement. Well, in fact, it's two if statements. One greater if statement up here that uses blocks in the if and the else clause. We've got a smaller statement in here that just happens to not use blocks. It happens to use single statements in either case, although this if statement in here is quite capable of using blocks as well, but it's just not in this particular case. So here's how the logic works. We come down here and we say, are you greater than 40? And if you are, we do this. Now, if we are not greater than 40, that means we're either equal to 40 or we're less than 40. And this second if statement is used to distinguish between those two possibilities. We're either equal to 40 or we're less than 40. So now this says if we're less than 40, then, well, we're young. Now if that is false, and that is false, then this final else, there's only one possibility for what this could possibly be. We must be exactly 40. So we're the perfect age. Most of you, I'm sure, will understand that. So please check this code, look over it, and see that it works properly. And see that you understand it properly, because it is a fundamental part of the C programming language. We're using an if statement inside an if statement. Well, we're actually using an if statement inside an else. But if you think about it, we could just take this code here, and we could quite as easily transplant it up into the top part if we wanted to. It will work in either place, although logically it may not make a lot of sense, but it will still compile and run. This is called nested ifs. Nested in the sense that it's an if inside an if, or in this case an if inside an else. Now that you've got your head around that, I'm going to confuse you. I'm going to recall our conversation about blocks. Remember I said that a block is a series of 0 or more statements. And I said that once you have, following an if statement, you must have either a block or a single statement. And the same applies to an else. That is true. It is still true. Now I'm going to confuse you by doing this. I've removed the curly brackets. I assure you that this still compiles and still does what it did before. Now you might be thinking to yourself, hang on, he said before that if you have an if or an else, what follows it must be either a block or a single statement. Now this, you're thinking, is not a single statement. It seems to be multiple statements, so therefore it must be enclosed in braces, curly brackets. And you are kind of right, except for the fact that it is actually not multiple statements. If it was multiple statements, we certainly would need brackets around it, but we don't. So hang on. Now I'm sure I'm confusing you, because there's 4 lines of code there. You're wondering whether I'm saying that 4 lines of code can be a single statement. There's actually 2 separate semicolons, one there and one there. So how can that be just one statement? Well, it's a compound statement. It's funny the way C works, but C treats this beginning to end as one statement. And if I had braces in here, like there, and there, and there, and there, and I had another statement here, x equals y, and another statement here, a equals b plus c, and so forth. All of that is still one statement. It's a very large, complex statement, but we call it the if statement. And the if statement starts here, and it ends here. So because it is a single statement, we're allowed to get away with not putting the braces here around the big else clause. I'll just undo all those. The magic of television, we're back where we started. Okay, so I hope I've assured you that this is exactly the same as we had before. This code will compile and run. If you don't believe me, I think we'd better check it. Okay, and run. Please enter your age. Okay, we'll try the less than case first. You're only young. Run it again. Try the greater than case. Okay, that works. And we'll try the equals case, where we're exactly 40. 40. You are the perfect age. Okay, so it is working as we expect. So I hope we're all convinced that the code below is accurate and working code. So now I'm going to mess with it a bit. The only thing I'm going to change is the white space. Remember that white space should not change the logic of the code at all. So you watched me there. I didn't change anything except deleting some white space. So theoretically, that program now should do exactly what it did before. I think you'll agree. Except I've kind of changed the way that a person might read it. It's no longer really a great big if statement with a smaller if statement embedded inside the else clause. Well, of course it really is still that, but we don't think of it as that anymore. Now we think of it as an if, followed by an else if, followed by an else. Now there's no really such thing as an else if, but we can pretend that there is, and our pretending will work because it still compiles and runs and does exactly what we want it to do. We don't think of this the way we thought of the large if statement surrounding a smaller if statement. Now we think of this as an if followed by an else if, followed by an else. We could actually, if we wanted to, here have multiple conditions. We could have if, else if, else if, else if, else if, else if, and finally an else. You might want to think of it like this. We could have if age equals 1, then do this, else if age equals 2, do this, else if age equals 3, do this, else if age, and so on. You get the idea. Followed by an else at the end, and the else at the end would be if the age doesn't match any of the above categories. If some of you have come from other programming languages, such as BASIC, where there is actually a formal construct known as the else if, this is C's equivalent. It's not, strictly speaking, an else if. It's really an else followed by an if inside the else, if you know what I mean. But it works for the purposes of what we're trying to achieve. So I hope you can see that this is sort of another way of approaching the problem. If age is greater than, else if age is less than, else it must be the same age. Okay, so now I won't actually manually construct it while you're watching, but I'll switch to a completed version of what I'm talking about. Okay, I took a moment there to add some extra lines of code to this program. Let's go and see what I've just added. Scroll down. Okay. If age equals 1. Well, first, before we go any further, let's check out the way of comparing two variables or constants to see whether they're equal. You use the double equals sign. Equals equals. That is how you say if age equals 1. Okay, now you know. We're going to look at that in more detail in a moment. If age equals 1, print this. Else, if age equals 18, print this. Else, if age is 21, print this. And so on all through your life. You can print out different things depending on what different age you are, and if you're not any of those ages, then it just prints out, sorry, your age is nothing special. I hope this is a good illustration of the way else ifs can repeat down the page. Now, you could completely change your indentation style here, and you could see, if you think about it closely, that all of this is contained inside the else clause of this one. And all of this is contained inside the else clause of this one. So we could completely redo that if we wanted to, and indent them differently, indenting every if statement one indentation further. But we won't do that because I don't think it adds anything to the readability of this program. I just wanted to give you a good example of how else ifs can proceed. Now, sometimes that's not the smartest way to code your program. And I'll tell you what I'm talking about. When you have a situation like this, where you're comparing an integer to a bunch of other exact integer numbers for equality, then you can replace that whole block of code with a single statement called a switch statement. Now, you can't always use a switch statement. Like if, for instance, if I'd said if here, if this is less than 10, then maybe a switch statement is the right thing to do. Alternatively, if I'd said if age equals magic age, then a switch statement wouldn't have been possible at all, because switch statements, as you'll see in a moment, only work with integer constants. That is an integer constant, that is an integer constant, that is an integer variable. Constant, not variable, is what we need for a switch statement. So I'll put that back. Okay. So, have a good look at this, because now in the next example I'm going to show you that entire section of code rewritten into a